Alright guys, I'm just going to do one of these just to kind of remind you. We'll go over a few, but just to kind of remind you what we're doing. So on these, you need to perform the operation indicated. So here, this one is a rational function multiplied by a rational function. This is a rational function divided by a rational function. Here is a rational function adding a rational function, and on the next page is a subtraction problem. So let's just kind of remind ourselves what we're doing here. When you're multiplying and when you're dividing, you can have different denominators. That's not a problem. When you're adding and subtracting, you need to get the same denominator. So when you're multiplying, you're just going to multiply the numerators, multiply the denominators. However, before you do that, you're going to want to factor to see if you, so factor first to see if you can simplify. So step 2 would be simplify. All right, so let's factor first. So here you're going to say what two numbers multiply to give me negative 12 and add to give me negative 1. That's going to be negative 3 and positive, or I'm sorry, negative 4 and positive 3. So this is going to factor into x minus 4, x plus 3. This, so that's this one. This, we've got what two numbers are going to multiply to give me 2 and add to give me 3. And that's going to be positive 2 and positive 1. So we're going to get x plus 2, x plus 1. So now we've factored this one. So then we look to this one. What two numbers are going to give me, multiply to give me 6, add to give me 5, and that's going to be 2 and 3, plus 2, plus 3. I could put these plus. So then I'm going to have, this is going to be multiplied by x plus 2, x plus 3, all over, and then that kind of loaner that doesn't need to be factored. They gave us a break on that one. Okay, and now we're going to look to see what if these are the exact same. What can we simplify? Can we cross anything out? And lo and behold, this x minus 4 divided by x minus 4 would give us 1, so we can cross those out. X plus 2 over x plus 2, those can cross out because x plus 2 divided, since I'm multiplying, basically you're multiplying those all across, so it's going to end up being one big problem right there. And so you can divide. X plus 2 divided by x plus 2 is going to give you 1. All right. So x plus 3 and x plus 3 are both in the numerator. You cannot cancel those out. They are both in the numerator, and x plus 1 is in the denominator. So we're going to be left with x plus 3 squared, x plus 1. And if you wanted to work that out, you would have it, if you wanted to FOIL this out, it would be x squared plus, and this is going to be 6x plus 9 over x plus 1. So either of these answers are fine. Okay, but just know that you need to be able to multiply that out. Now, with the division, it's the exact same thing, except for since you're dividing, you flip the second one. Lots of you guys are flipping this first one. Please don't. Flip second. So this would actually be 2x squared plus x minus 1 over x squared minus 2x minus 15 times x plus 3, x minus 1. I just flipped this second grouping. And now you're going to have to factor those out and see what you get and see if you can multiply them out or simplify them. I'm not going to do that one. You guys do that one. But I'll tell you, your answer is going to be, should I tell you? Maybe I won't. Maybe we'll talk about that later. All right. This one you're adding, so you must have a common denominator. What that mean? Wait, oh, I totally did not spell that right. Denominator. Which means that these need to be the same. So you need to make sure that those are the same, and if they're not the same, you need to figure out how to make them the same. So x squared minus 9, I can rewrite this to 2 over x plus 3 plus 4x, and I'm going to factor this out. And I know that when I have it like this, if you think about it, if you want to do it the long way, you're going to say what two numbers multiply to give me negative 9 and add to give me 0. And that would be plus 3 and minus 3. So I can factor that as x plus 3, x minus 3. And if I were to multiply those back together, x squared minus 3x plus 3x would give me 0x. Positive 3 times a negative 3 is going to give me negative 9. So that multiplies back to give you that. Now, I also noticed that these have this in common, but I'm missing this. So you can multiply by x plus 3, or x minus 3 over x minus 3. Now you're going to have the same denominator. So when I multiply these together, I'm going to get 2x minus 3 over x plus 3, x minus 3, plus 4x over x plus 3, x minus 3. Now that I've got the same denominator, that's just like saying 1/2 plus 4 over 2. I have the same denominator, so you just add your numerators and you get 5 over 2, which is 2.5. But when you have the same denominator, then all you do is then you add your numerators. Or subtract, depending. Here it's saying adding. So you're going to have 2x minus 3 plus 4x all over x plus 3, x minus 3. Now let me warn you, if you cancel these out, it will be wrong. Do not cancel those out. All right. Distribute this out, and you're going to get 2x minus 6 plus 4x over x plus 3, x minus 3. The reason you can't cut those out is because of this plus sign. They're not being multiplied. If they were being multiplied, you could. But since you are adding this 4x, you cannot cut that out. You can't simplify that. It's like saying, this is the same thing as saying 2x plus 6 divided by 2x. That's not the same. You cannot cut those out. That's a no-no. Don't do that. Okay? All right, so then you get to this. Now I can combine my like terms, and I'm going to get 2x minus 6 plus 4x is going to be 6x minus 6 over x plus 3, x minus 3. That is a perfectly fine answer. If you want to factor out that 6 and say 6x minus 1 over x squared minus 9, that's another perfectly fine answer. This is a good answer. This is a good answer. 6x minus 1 over x plus 3, x minus 3. That is a perfectly good answer. These are all the same value. Ooh, gosh, sorry. These are all the same value. Does that make sense? I took this, went off the grid a little bit, sorry. Combine my like terms, kept my same denominator. The denominator is the same every single time. This is the same as this. Okay, hopefully that helps. When you go to the next page and do these have the same denominator, so you just take it and you subtract it. So this is basically just going to be x minus 6 minus 8x plus 7 all over x plus 5. Since I have the same denominator, the denominator does not change. The only thing you need to make sure you do with this is distribute that negative. So you get x minus 6 minus 8x minus 7 all over x plus 5. Why am I not changing the denominator? Because we're subtracting. When you're adding and subtracting, the denominator stays the same. Okay, then you combine your like terms, and you're going to get negative x minus 8x is going to give you minus 7x. Negative 6 minus 7 is going to give me minus 13 over x plus 5. And that is as simplified as you can get that. That's it. That's your answer. Okay? This one you do not have a common denominator. So you're going to have to factor this out and say what two numbers multiply to give me 36 and add to give me negative 13. This is positive. And I'm going to tell you it's negative 9 and negative 4. So you're going to be left with 7 over x minus 9 equals 2x minus 6 over x minus 9, x minus 4. So I've factored this into this. Now how do you get the common denominator? You're going to multiply by x minus 4 over x minus 4. You're going to be left with 7x minus 4 over x minus 9, x minus 4. And oops, I put equals. I didn't mean to put equals. I meant to put minus. Minus 2x minus 6 over x minus 9, x minus 4. Now I have a common denominator. So I can just combine my 2 and get 7x minus 4 minus 2x minus 6 all over the one denominator. Now when I work this out, you're going to get, well, maybe you guys can work that out and see if you get the right answer. Distribute this, then combine your like terms, and see what you find. All right, that's it for this section.